All right, today we're going to be solving the three-sum with two-pointers traversal. This is problem 15. It's the LeetCode Medium. So given an integer array of nums, return all the triplets so that they are not the same index, nums I, j, and k. I doesn't equal j, I doesn't equal k, j doesn't equal k, and that they all add up to 0. So basically, we can't have any duplicate triplets, so we should treat all these as like, individual sets. And the sum should be 0. And then here are the bounds. So we will always have 3 elements. Okay. So first, I guess we can create our return variable. And we'll do an array list for easier access and adding. So step 1, sort. Let's just sort the array. We're doing this, makes it easier to identify duplicates by checking previous values. Then we're going to iterate through. So what we're going to do is we're going to do a two-pointer approach. So we'll have a left and a right pointer, and we'll be iterating on I. So we're going to use the I to find the first element. We're going to move the left to find the second, and the right from the end to find the third. And we can check for duplicity on all of these stages so that we can avoid adding in duplicate sets because order doesn't matter in a set. So ABC also equals BAC, also equals CBA, etc. So we want to avoid duplicates. So we want to do duplicate checks on the left, the right, and the current index. So let's go ahead and start with this two-pointer approach. Into I equals 0, I is less than nums.length minus 2, because we're doing a two-pointer approach. We need to have 3 values that we're checking. And if we were to do just minus length, then we'd have index out of bounds. So we're going to skip the duplicates for first. If I is greater than 0 and nums of I equals nums of I minus 1, continue. So this will skip the duplicates for the first. Saves us from finding the same triplet multiple times. Okay. Now, let's think about this mathematically. Okay. So if we have I plus k plus, or I plus j plus k equals 0, basic algebra, we are starting with I. So let's take that, move I to the other side. Now we have j plus k equals negative I. Okay. So that's what we're going to be using to kind of calculate these sums. It's not too hard. So target sum, right? What we want to find is negative I. Okay. Now, left equals I plus 1, and then to right equals nums dot length minus 1. So we're going to start the right pointer at the end. And then the left pointer at the beginning plus 1. So that way we can, I'm sorry, my video's mirrored. I guess this is the left side. So we'll be coming in like this. So left will be incrementing and right will be decrementing, and we're going to be checking to see if we can find triplets. Boom, efficient. We don't have to run through multiple times. Now we're going to do the two-pointer technique. So it's a while loop. While left is less than right. We're going to get the current sum. Now we have the current sum. If current sum equals target sum, then we found a triplet. So we'll just add this. We'll do added arrays dot as list, and we're going to add nums I, nums left, and nums right. Okay. Now, remember what I said about skipping the duplicates? So we skipped the duplicates for the first. Now I want to skip the duplicates for the left, for the second. So we're going to increment left because we just found the element, so we want to move the pointer. But we also want to check and see. So while left is less than right, and nums left equals nums left minus 1, left plus plus. So this is just checking to see that we don't have duplicates for the second element as we iterate the pointer over. Because if we found the matching pair on one left, we move it over. We don't want to add that same number. Okay. Now we got to do the same for the right. So we're decrementing the pointer because we're going to keep iterating down the array. And now we just do a simple check, just like we did there. While left is less than right, and nums of right equals nums of right plus 1, since we're decrementing. Okay. And so this will handle the duplicates. I guess I should I can clean this comment to make a little more sense. Okay. So we've checked for duplicates. So this accounts for if the int is if it's a match, right? So this is if it's a valid match. If it's not a valid match, all we want to do is check and see which pointer we want to move. So if it's not a match and the current sum is less than the target sum, then we know that we need to increment the left side. The sum is too small, so move the left pointer to increase the sum. Else, the sum is too large. Decrease the right pointer to decrease the sum. Then we're going to return So we're out of this loop. We're out of that loop. Threesome results. AKA me and Cabo. All right. Thanks for having a threesome with me, first of all. It was very emotional. I like that we didn't maintain eye contact. And yeah, two-pointer problem. Some of the main things that will trip you up on this problem are just trying to figure out how to account for those duplicates. Like, because that is a little bit tricky. So the main thing to keep in mind is like a set ABC is equal to BAC is equal to CBA is equal to, any form of that. So we can't have duplicates. And by adding in these checks for the first element, the second element, and the third element not being duplicate and moving the pointers, we account for that. And by doing a two-pointer problem, like a two-pointer approach, we're getting very good big O. It's O of n squared, which is great for this problem. It would be n cubed otherwise. And yeah, it's a really good way to approach this problem. And I hope it makes sense and helps you out. Till next time.